It's something we all just take for granted, right? You pull out your phone, pop open a map, and bam, a little blue dot shows you exactly where you are. But that same piece of magic has a much, much more important job, saving your life in an emergency. So today, we're going to break down exactly how it works.
I mean, really think about it for a second. You're in trouble, you make a call, and somehow help just knows where to go. It feels so simple, almost automatic. But the crazy thing is, just a few decades ago, this was a huge, life-threatening problem with no easy answer.
That's right. Back when mobile phones were just starting to explode in popularity, this incredibly dangerous gap opened up. If you called 911 from a cell phone, dispatchers had absolutely no idea where you were. It was a massive public safety crisis, and it demanded a solution fast.
So how do you even begin to solve a problem like that? Well, it wasn't about one company inventing some new gadget. Nope, it took a full-on federal mandate, the E911 rules, to force an entire industry to get to work and innovate. And that, right there, is where our story really begins.
See, finding someone on a landline was a piece of cake. The phone number was directly tied to a physical street address in a database. But a mobile phone, that was just a signal floating around in the air, completely anonymous, totally untraceable.
So in 1996, the FCC finally stepped in and laid down the law with something called the Enhanced 911, or E911 mandate. And this wasn't just a friendly suggestion. It was a direct order to all the wireless carriers. You have to figure out a way to locate your callers during an emergency, period.
The whole thing rolled out in two big stages. Phase I was, a pretty basic first step. Just tell us which cell tower the call is coming from. Which is better than nothing, I guess, but that could still be a search area of miles and miles. Phase 2, though, that was the real game changer. It demanded the precise latitude and longitude of the actual phone, accurate to within just 50 meters.
Okay, so you need to find a tiny phone with that kind of incredible precision. The obvious answer, the one everyone thought of first, was the Global Positioning System, or GPS. But as engineers very quickly found out, GPS had some really serious kind of hidden flaws when it came to life-or-death emergencies.
At the time, GPS really did seem like the perfect solution just waiting to be used. I mean, this amazing military tech was finally available for everyone. But it turns out, in a 911 call where every single second is critical, standard GPS just wasn't fast or reliable enough on its own, not even close.
And it's not like GPS was some brand new, unproven thing. By the time the E911 mandate came along, the system was fully mature, with decades of development behind it. The technology was solid. The problem was, it was never, ever designed for this kind of urgent, life-on-the-line task.
And this is really where you see the fundamental problem. E911 demanded a location in just a few seconds. But a standard GPS chip, starting up from scratch in an emergency, what they call a cold start, could easily take over a minute to figure out where it was. In a crisis, a minute is an eternity.
So this all boiled down to two massive problems. The first was that huge delay, which has a technical name, time to first fix, and the second was the fact that GPS signals are incredibly weak, which, as you can imagine, created a whole other world of issues.
So this time to first fix, or TTFF, that's literally the time it takes for your phone's little GPS receiver to download a bunch of data from satellites way up in space just to get its bearings. If your emergency call is over before your phone can even get that first fix, the entire system is basically useless.
The second problem is all about signal strength. These GPS signals travel over 12,000 miles from space. By the time they get to your phone, they're unbelievably faint. So, if you're inside a building or deep in a parking garage or in a dense city, exactly the kinds of places where emergencies happen, those signals might not get through at all.
So if standalone GPS wasn't the answer, then what was? Well, the solution they came up with was truly ingenious. It was this idea that instead of having the phone do all the work by itself, what if the entire cellular network could lend a helping hand? And that idea led to a breakthrough: assisted GPS.
The core idea behind Assisted GPS, or AGPS as it's called, is all about teamwork. The moment you need a location, your cellular network shoots your phone a tiny little packet of data. They call it assistance data. And that little packet of data, well, that's the secret sauce to everything.
The best way to think about it is like this. The network gives your phone a cheat sheet. It contains all the crucial information the phone would normally have to spend a solid minute searching the skies for.
And with that cheat sheet, it can solve the whole GPS puzzle almost instantly.
To really get why this is such a game changer, you have to know what the phone is doing on its own. It's basically searching blind. It has to scan this massive range of frequencies and codes, trying to find and lock onto a satellite signal. It's that huge, time-consuming search that causes the long delay.
But with that assistance data from the network, push. That entire massive search space just collapses. The network literally tells the phone, hey, these are the satellites that are right above you, and here are their exact frequencies. So the phone goes from searching everywhere to looking in one tiny, specific spot. And the result? A location fix in just a couple of seconds. It's brilliant.
And here's the really cool side effect. Because the phone isn't wasting all its energy scanning the entire sky, it can focus all of its power on listening really carefully for those faint signals in that one little spot. And that's what gives AGPS the incredible sensitivity to work indoors, solving that whole weak signal problem too. So, this incredible technology, AGPS, it was literally born from the life-or-death pressure of the E911 mandate. But its story definitely doesn't end there. It's now the invisible engine that powers so much of our modern digital world.
In fact, and this is a quote from the research we've been looking at, without the intense pressure from E911, AGPS would have probably just stayed a niche idea, maybe never even deployed. A public safety crisis directly created a technology that, today, we all use every single day. Just think about it for a second. Every time you open up Google Maps, or call an Uber, or check in on Facebook, or play a game like Pokémon Go, you are using AGPS. That fast, rock-solid location fix you always get, it comes directly from the technology that was pioneered for emergency calls. So a system that was designed to find you in your absolute worst moment now helps you navigate all of your best moments. It really makes you wonder, doesn't it? What critical public need out there today is forcing engineers to create the next piece of invisible magic that one day will completely reshape our world?